Dear students, welcome to my next lecture. Myself, Dr. Arulprakasam, Associate Professor, Department of Mathematics, SRM Institute of Science and Technology, Katangattur. Last two lecture, we discussed what is Fourier series in the full range series expansion. What is the necessary condition for existence of Fourier series expansion? So in the interval 0, 2 pi, it's a full range. I explained some number of problems, and then I'll move on next to type 2 is suppose function defined in the interval minus pi to plus pi, it is also full range. How we classify the problem in this interval defined, function is defined in the interval minus pi to plus pi. So in this interval we can discuss three cases of problem. One, because by following function category classification we can classify three type of problem. Suppose case 1, function is odd function. So then by the integral property, odd functions, the Fourier coefficient value a0 and an value 0 always, and bn coefficient only exist. The formula, coefficient formula, nothing but 2 by pi integral 0 to pi f of x sine nx into dx. Why? By the integral property of integral minus a to plus a f of x into dx. By the integral property, suppose function is odd means always integral value 0, even means 2 times of integral 0 to a f of x into dx. Following this integral property, we can define this one case of problem. So what is the Fourier series expansion? Suppose function is odd, the Fourier series expansion nothing but f of x is equal to summation n is equal to 1 to infinity bn sin nx. Other coefficient value 0. Directly we can write out this formula and substitute the value. Okay, what is case 2? Suppose function is an even function, then bn the Fourier coefficient value bn value 0. So the other coefficient a0 and an should exist. The formula nothing but a0 formula 2 by pi integral 0 to pi f of x dx, and an formula 2 by pi integral 0 to pi f of x cos nx into dx. So there was Fourier series expansion nothing but f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx. What is case 3? Case 3 nothing but suppose function either even nor odd, then all the coefficients should be exist. The formula nothing but just how we are done in the interval 0 to 2 pi, we can modify minus pi to plus pi. That's it. Just to find out by using the integral formula, find out coefficient value a0 and an, bn value, and simply substitute them for Fourier series expansion here. So now I'm going to discuss some standard function defined in the interval minus pi to plus pi, how to find the Fourier series coefficient. Suppose find the Fourier series for the function f of x is equal to x in the interval minus pi to plus pi. What happened? Easily we can able to understand here given function is odd function. How we can classify it is odd or even? So we know the case. Suppose f of minus x is equal to minus f of x means it is odd function. Suppose plus f of x means it is even function. You know it in the schooling level you study. Suppose either minus f of x not plus f of x means that is either even nor odd. This is the condition for testing given function is even or odd, neither even or odd. So clearly we can able to understand here given function is odd function. Odd function means what happened, what is the Fourier series expansion existed. So what about this function is even function because of x f of x equal to x square in the interval minus pi. First look out the interval is minus pi to plus pi, also full range. So after that directly we can verify it is even function or odd function. Even function means what is the Fourier series expansion. Odd function means what is the Fourier series expansion. That's it. The mod x always even function. It is either even nor odd because e power x. Okay, sin x, sin this the following problems very standard problem I listed, and also simple problem I listed here. I'll do one or two problem. It is constant function. You know, always constant function is even function or odd function. So it is always even function, right? So I can go for one problem for our understanding purpose. Suppose I am taking the problem f of x is equal to x in the interval minus pi to plus pi. So just we can understand it is odd function. So what is the odd function? Fourier series expansion. Odd function means just listed. Here given interval is minus pi to plus pi. Function is odd. Function is odd. Therefore, the Fourier coefficient value a naught and a n value always 0. I listed. Look at this. Function is case 1. Function is odd means Fourier coefficient a naught and n value 0. Only coefficient value bn value exists. So just I am taking here. So bn. What is bn coefficient formula? Bn is nothing but 2 by pi integral 0 to pi f of x sine nx into dx. Just to find out the coefficient value 1 by pi integral 0 to pi. What is function value? Here x. What is function? Sine nx into dx. Just integrate by using the Bernoulli formula. Already last three class I discussed this Bernoulli formula. So 2 by pi, just write out what is the function, u function. It is our suitable u function. What is our dv form? It is dv form. Find our sine nx integration value. Sine nx integration value minus cos nx divided by n. Once you form u and v and execute these remaining other terms of the Bernoulli form. So by the formula minus x differentiation value 1, cos nx integration value sin nx divided by n. Already I have n, so n square. Next term will be 0 by the formula. Just substitute limiting value 0 to pi. So 2 by pi, substitute upper limit first. Here pi, so minus cos any, here odd and even number of pi value, cos n pi divided by n minus sin any number of pi value 0 minus minus plus. So upper limit minus lower limit. If you are substituting x instead of x to 0, I am getting 0, sin any number of value 0. So my answer is pi pi cancelled. So minus cos any number of n pi value minus 1 whole power n divided by n. Because odd number of value minus 1, even number of value plus 1. So I can rewrite this one minus 1 whole power n plus 1 divided by n. It is for our Fourier coefficient value. Directly write your Fourier series expansion. Therefore, the Fourier series is nothing but f of x is equal to summation n is equal to 1 to infinity pn sin nx. So now I can simply substitute bn value here. So what happens? Summation n is equal to 1 to infinity, or a bn value minus 1 whole power n divided by n sin nx. It is for our Fourier series expansion. Function defined in the interval minus pi to plus pi. Also function is odd function. Likewise, try to get even function x square. So mod x, it is either even nor odd. So what about, suppose I can take one even function type of problem. Suppose I am considering problem 2. So just take problem 1. What about problem 2? Suppose I am considering the problem 2, function f of x is equal to general formula k. The interval function defined in the interval minus pi to plus pi. K is any constant function. Maybe sometime k value may be 1, 2 or 5. Some number is defined. We can simply substitute instead of k value. That's it. So it is, look out the here problem. Here function always even because of f of minus x is equal. There is no x. So I am getting k. It is always getting f of x. Therefore given function is even function. So what is the even function? coefficient even function defined. What is the coefficient formula? So always bn value 0. It will come some MC question also. So therefore the Fourier series expansion f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx. This is the coefficient of Fourier series expansion, where what is an formula, a naught formula, 2 by pi integral 0 to pi f of x into dx. So I can substitute 2 by pi integral 0 to pi. What is your f of x function? K. K. So k into dx. Here k is constant. Just taking outside, so k times. So integral 0 to 2 pi dx integration value just x. Now simply substitute function value 0 to pi. So what happened here? Pi 2 pi 2k by pi. Substituting upper limit is pi, lower limit is 0. So my answer is pi pi cancel. The answer is 2k. It is for A naught. Similarly, how to find an formula? So an formula nothing but 2 by pi integral 0 to pi f of x cos nx into dx. So 2 by pi integral 0 to pi f of x value just k cos nx into dx. What about k? So it is constant. Just taking outside the integral, 0 to pi cos nx into dx. What is cos nx integration value? 2k pi. Cos nx 2k pi cos nx integration value sine nx pi n 0 to pi. Sine any number of pi value 0. So sine 0 0. So an value 0. So therefore my answer is f of x is equal to a naught by 2 just 2k by 2. This value 0. So hereafter just try to the list of the problem, even function and odd function given, how to do. Suppose even or neither even nor odd given, find out all the coefficient value. Thank you students. We'll discuss next class.